So you are welcome to another edition of our online class. So last week we started a discussion on error and approximation. So inshallah we are still going to continue on that. And we stop at significant figure. Now today we start from decimal places. So what do you mean by decimal place? So this involves, as you can see there on the board, it involves an approximation of values to a given or a certain number of figure of value or digits after decimal. So what do we mean by digit after decimal? Those numbers after decimal. So which means that if you want to find the decimal or you want to round up a particular number to a decimal places, the counting of decimal places starts from the number after decimal, unlike the significant figure. Now, example, we want to consider this example. We want to round up the number 28.5631 to 1 decimal place, 2 decimal places, and 3 decimal places. So we have the first one. So we have 28.5 to 28.5631. You see now, when you hear the word decimal place, you should know that all the operations you are going to carry out, you are going to start from all the operations you are going to carry out, so they are going to start from the number after decimal. The number after decimal. Are you getting it now? So which means this is your decimal. You don't have business with this side. You only have business with this side. So this side is this, all this side you need is sides after decimal. Now for the first one, so 1 decimal place is now 1 decimal place. So definitely this is the first number after decimal. So which means this is the what? 1 decimal place. Are you getting it now? But since the number that follow this 5 is 6, so 1 DP is on this, it falls on this, no doubt. Now the number that now follow that 6, that 5 is 6. So this thing, this is, you round this 6 up to what? You round this up to 1. Are you getting now? You round this thing up to 1. So when you add that 1 to this 5 now, it makes what? 6. So which means to decimal, 1 decimal place, you have 28.6. Are you getting that? Because this 6, this 1, you add that 1 to this, you know 5 plus 1, you give you what? 6. So you have 28.6. Are you getting it? Then to 2 decimal place. To 2 decimal place, which is the second one. So to 2 decimal place, we have a 2 decimal place falls on this. So to 2 decimal places. So 2 decimal places, it falls on where? So 2 decimal places falls on this 6. Are you getting now? It falls on this. 2 decimal places falls here. So the number after that 2 decimal places is what? Is 3. So which means this 3 we round down the 3. The 3 is not up to 5, which means you are going to round it down to 0. Abi? Yeah? So when you round it down to 0, you add that 0 to 6 here. So which means to 2 you have 28.556. Are you getting it now? Then to 3 decimal places, it should be what? So 3 decimal places is here. So this is where our 3 decimal places is. So this one you round it to 0, so we have 28.563. Are you getting it now? So that is to 3 decimal places. Then let's consider the one with 0. So let's consider this example 2. So we consider or explain in details. Explain in details. Consider 0.00547 and explain Now, we want to consider this 0.00547. Are you getting it now? So we want to consider that one. So let's move on to, let's use this side. Solution now. So solution. So we have 0.0000547. So we have this now. So we want to consider its decimal places. Why do I choose the kind of question? Now, the first thing is, let's start. How many things do we have here? So let's consider this. So let's just consider from 1 decimal places, maybe to 5 decimal places. So the first one now, let's say to 1 decimal places now. To 1 decimal place. To 1 decimal place. Look at it, unlike significant figure. You know, in significant figure, I told you that the zeros that start, if it is 0 that starts the value, that those zeros will not be counted. But in decimal places, you don't have business with the number that starts or the numbers that start after decimal. You know, decimal places means the numbers after decimal. Now, since it's now 0 that starts, they didn't call it decimal value. They don't call it decimal figure. It is called decimal places, which means whether it is figure or not figure, you are going to count it. Are you getting it? So it is not decimal figure, it is decimal places. So which means that anything you see after that decimal should be counted. So which means that this thing now, if you want to consider this thing to 1 decimal place, it should be what? It should be 0.0. Are you getting that? Because we have this 0. To 2 decimal places now also, that should be 0. You see, this is 1 dp, 2 dp, 0, 0. Are you getting it? To 3 decimal places, it should be 3 decimal places, so we have 3 decimal places here. Now, after this 3 now, the number that follows is what? Is 5. You add up that 5, you add it to this, so which means you have 0.001. When you continue like that, we see that to 4 decimal places, we have 0.00005. Are you getting this now? Then to 5 dp, we have 0.00055. Then 6 dp, which is the given question, that is 0.000547. So we see that starting from here now, so we have what? Starting from here, we have unique values or answers. So this one, they are what? That is the non-unique. See now. So all this one, these two, they are just meaningless. So starting from this one, they are the one that is meaningful. So when you see it from this 3 decimal places is equivalent to 1 significant figure, right? This one is equivalent to what? This one is equivalent to 1 significant figure. The same thing here also. This thing is also equivalent to 1 significant figure, because you know significant figure starts from here now. So significant figure starts from here. So this thing is equivalent to, this one is equivalent to 1 significant figure. This one equivalent to 2 significant figure. Why this one is equivalent to 3 significant figure. So when you see this, let's assume it is significant figure now. You know, significant figure will start from here. So this one is equivalent to 1 significant figure, equivalent to 2 significant figure, and equivalent to what? 3 significant figure. Are you getting that? So this one is, that is the equivalent value. But since we are not finding the significant figure, so I just put it there so that it will be clear to you. Then After this, let's move on to what we call limit of accuracy. So limit of accuracy. Limit of accuracy. Limits of accuracy. So that's the another one we are going to consider. So limit of accuracy. What do you mean by limit of accuracy? Let's start. You know when a quantity is measured, comma, so there is always an error. There is always an error. There is an error. No matter how careful, no matter how careful the thing is made, no matter how careful the measurement is made. Measurement is made. Thus, any stated measurement is an approximated value. Any stated measurement or value. Any stated measurement is an approximated value. It's an approximated value. It's an approximated value. So which has been rounded to a certain number, which has been rounded to a certain degree of accuracy. To a certain degree of accuracy. To a certain degree of accuracy. For example, let's consider this. For example, comma. So if the length of a block is given as 10, if the length of a block is given as 10 centimeter. Comma. So the actual value of that length is not 10 centimeter. So if it is given, I said it start with the nearest centimeter. The actual value of the length, the actual value of the length is possibly between 9.5, is anywhere between 9.5, to what? To 10.4999, so 10.499 centimeter. What do you mean by this? It's something you can even consider now. So, how? Let's look at it. Say the value is given as 10, right? It's given as 10. So, you see the value is given as 10 now. So, 10 centimeter. Given value is what? Is 10 centimeter. So, the nearest what? 10 centimeter to the nearest centimeter. The nearest centimeter. So that nearest centimeter simply means to the nearest 1 centimeter. That's the meaning of it. 1 centimeter. So, you know, the half of that one is what? Is 0.5. So half of 1 is 0.5 now. So half of 1 is what? 1 over 2, which is 0.5. Are you getting me now? So half of that 1 centimeter. So which is this? So which means that you subtract, if you subtract that, so the limit of accuracy should be the limit of that 10 centimeter should be what? 10 centimeter plus or minus 0.5 centimeter. So which means that is either you deduct 0.5 from that 10 since the value is approximated to the nearest centimeter. So half of that centimeter is 0.5, which means it's either you add that 0.5 to this or you deduct. You know, when you add, so you have what you call lower limit, which is lower bound now. So lower bound will be what? Or lower limit. That should be 10 minus 0.5, which is what? Which is 9.5 centimeter. Then the upper limit should be 10 plus 0.5, which is what? Which is 10.5 centimeter. Now, but we know that the value can start from what? From 9.5, because 9.5 can be approximated to the nearest meter as what? As 10, right? All the value from 9.5 up to 9.6, 9.7, 9.8 and so on, it can be approximated to the nearest meter as 10 centimeter. But this one, the value must not reach 10.5, because when you approximate that 10.5 should be what? Should be 11. So what I'm saying is this, you know, you can approximate this thing, approximate the value of this 9.5. 9.5 can be this. Are you getting it now? Can be approximated to be this, to be 10 centimeter. To be 10 centimeter. Right? Up to 9.9. But this 10.5 now, when you approximate this, you see that it is what? That should be 11 centimeter. So, but when you have 10.4999 and so on, this one is what? Is also this. So which means this thing, the value must not reach this. Are you getting it now? The value may be this, and it may also be what? Be that one. So which means the range of that value will now be what? So the limit range will now be, so the limit range is now what? Will now be 9.5 centimeter. So 9.5 centimeter less than or equal to 10 centimeter, but less than what? 10.5 centimeter. I hope you get it. So the meaning of this range is telling you that the value starts from 9.5, but does not reach 10.5. That's the meaning of this. So which means the value of that length, that has been approximated to 10 centimeters as the nearest meter, as the nearest centimeter, can be between this 9.5 and 10.499999 and so on. Then the second one, example, let's consider this number 2. Okay, I'll give you some so that you go and do that one. So example 2 now. Another example. So the error of measurement, that this 0.5 is considered as the what? As the error of measurement. So this, look at it. So this 0.5 now, this 0.5, are you getting now? So that this 0.5, you look at it, see. So we call it what? That plus or minus 0.5 centimeter is called the error. It's called the what? The error of what? The error of the measurement. The error of the measurement. It's called the error. It's called the error of measurement. The error of measurement. Are you getting it? So why this one is called lower bound, this one upper bound. So let's continue. Okay, you don't see it. So it is called the error of what? Error of measurement. Hope you can see it clearly. Error of measurement. It's called error of measurement. So example 2 now. I want to consider this. Example 2. Example 2. Find the limit of accuracy. Find the limit of accuracy. Find the limit of accuracy of the following. The first one is 78 meter. 78 meter. To the nearest, correct? To the nearest what? The nearest meter. To the nearest meter. Nearest meter. B, we have 790 kilogram. To what? To the nearest 10 kilogram. To the nearest 10 kilogram. Then C, we have 0.58. 0.58. To what? To the nearest. To what? To 2 dp rather. To 2 decimal places. Then we have D, which is 576 so that is 40. To the nearest what? I think that should be to the nearest 100. I think so. To the nearest 100. Nearest 100. So we want to consider all this one now. So solution now. For the first one, which is 78 meter. So that's 78 meter now. To the the nearest meter. So that nearest meter means nearest 1 meter. So the nearest meter. So it is the same thing as 1 meter. So the half of that one is what? Is 0.5. So half of that one, so half of 1 is what? Is 0.5, which is 1 over 2. Half of 1 is what? 1 over 2, which is 0.5 meter. So which means the limit of accuracy here is plus or minus 4.5. Sorry, the error of measurement there. So therefore, error of measurement there is what? Error of measurement is equal to plus or minus 0.5 meter. So which means the value should be, upper band will be what? So the lower band will be what? We have lower band to be 78 minus 0.5, which is what? So what's 78 minus 0.5? So that should be 77.5, right? So we have 77.5 meter, right? And we also have the upper band, which is upper limit as well, equals to 78 plus 0.5, which is what? That should be 78.5. But we know that the value must not reach 78.5. We all know that, right? That the value must not reach 78.5. So which means the value should be between 77.5, right, and 78.499. So the value should be between, the value lies between 77.5 to and 78.4999 meter. Are you getting it now? So which means our limit of accuracy should now be what? So the limit of accuracy should be, limit of accuracy will now be what? So limit of accuracy will now be 77.5 meter, 77.5 meter, less than or equal to 78 meter, less than or equal to 78 meter, then less than 78.5 meter. So that is that for that one. Then for the second one, which is this one now, let's move on to the second side. That one which is B. Equation B. B now. What is the in B? 790 kilogram. 790 kilogram to what? The nearest 10 kilogram. To the nearest 10 kilogram. 10 kilogram. So half of 10 is what? Half of 10, that 10 kilogram is equal to 10 over 2, which is 5 kilogram. right? 5 kilogram. So which means the limit here should be between what? So the error of measurement here is what? The error of measurement. The error of measurement is what? Plus or minus 5 kilograms. So which means the limit should be, so the limit here is 790 plus or minus, so 790 kilogram plus or minus 5 kilogram. Are you getting it now? So which means the upper, the lower limit, which is bound, lower limit is what? 790 minus 5. So 790 minus 5, everything in kilogram, minus 5 kilogram, which is what? So that is a 785 kilogram, right? 785 kilogram, I think so. Then the upper limit equals 790 kilogram plus 5 kilogram. So that is 795 kilogram. 795 kilogram. Are you getting it now? So 795. You see that the error there is plus or minus 5. So since that the value should be between what? The value should now be between that 785, right? But it must not be what? It must not be up to 795. So which means the value should be between, so we can have 794 point what? Or let's say 795, yes, 795.499999 and so on, rather. So which means from there we can have, since the lowest thing here is the real value is 790, and then we already have a 7, so which means we can have 794 rather, 0.499 and so on. All those values should be approximated for 790. So the value lies between what? Between 785 and what? 785 kilogram, because any of these value can be, 785 can be approximated to 790, and so 795, that 795, just subtract 0.5 from that 795. You know, when you have that 795 now, 795 minus 4.5 now, it should be what? It should be 794.5, right? So which means if you have that 794.5, the value will still be what? So if you see that this one, when you are playing this, the value will be what? Be this. But when you have something like 7.49999 and so on, you see that to the nearest 10, the value should be what? Should be 790. Are you getting that? So it should be, so when you have 794 here, at the end of the day, sorry, you have 794 up to this. At the end of the day, the value should be what? It should be 790 now to what? Nearest 10. To nearest 10. Are you getting it? So to nearest 10. So which means the value should lie between what? Between 785 kilogram, between 785 kilogram and 784 and 7994.499 kilogram. So which means we have the limit of accuracy. Limit of accuracy is 785 less than or equal to 790. Let me put kilogram here. Less than or equal to 790 kilogram. 790 kilogram less than what? 795 kilogram. 795 kilogram. So please take note of the sign. You see, this one is less than or equal to, and this one is what? Is less than. Are you getting that? Which means the value is not up to what? It's not, the range is not, which means the range is not to 795. So take note of it, please. This one is less than. Why this one is less than or equal to? So that is that. Then the third one, I will do the third one. Then the last one, I will leave that one for you as an assignment. I leave the last one for you. You do that one as part of your assignment. So C, which is what? 0.58 to what? To 2 decimal place. To 2 decimal place. How do you do this? So two decimal place is here, right? Look at it. This is 1 decimal place. This is 2 decimal place. 1 decimal place. 2 decimal place. You see that these 2 decimal places now is falls on this part. Are you getting now? So 2 decimal places falls on what? On that, on 8. So which means we have a 0. Let me write it clear. So 2 decimal places lie falls on what? On 8, right? So that 8, if you look at it, is what? So we have a 10th here. So which is what? Which is the 100? Which is what? Which is nearest? Which is equivalent to what? Which is equivalent? Equivalent to nearest what? Nearest hundredth. Are you getting now? You see, it is nearest hundredth, not 100 though. Are you getting it? Not this. Right. So it is nearest hundredth. So you know nearest hundredth is what? Is what? So nearest 100 is this. For example now, take note of this. Nearest 100 is this. Nearest 100. Nearest 100. Nearest 100 is this. Means what? Means 100. Why nearest 100 means 1/100. Hope you can see the difference. This one is nearest 100, while this one is nearest 100. So please take note of the difference. So which means here now we are using this now. Are you getting it now? We are using that one. So which means the half half of nearest hundred, or let's do like this. So nearest hundred we said is this. It's equal to 1 over 100, which is what, 0.01, right? So its half is 0.01 divided by 2, which is 0.005. Hope you get it now. So therefore, the error of that measurement, is plus or minus 0.005. Are you getting this now? So which means our lower limit is equal to so we have the limit equals 0.58 plus or minus 0.005. So lower limit should be 0.58 minus, so lower limit is 0.58 minus 0.58 minus 0.005. That one. 0.58 minus 0.075. Which is, you have lower limit to be what? 0.58 minus 0.07 is 0.575. 0.58 minus 0.005, which is what? 0.575. And we have the upper one to be 0. That one should be 0.585, I think. So the next one we have upper limit, which is what? Should be 0.58 plus 0.005, which is what? 0.585. So from there now, you see that this one can be approximated to 2 decimal places. For this one, which means the values will lie between what? So the value lies between 0.575 and what? That lies between 0.575 and 0.5849999 and so on, like that. Are you getting it now? Because any of these values can be approximated to what? To 2 decimal places and still give us 0.58. You see that when you approximate this to 2 decimal places, so you will have 0.58. This one also we have 0.58 if you check it, right? So which means the answer, the limit, the reason for that is because 0.57, you approximate it, you will be what? It's got to give you 0.58 to 2 decimal place, right? Then also 0.5749999 and so on. Also, it also give us 0.58 to 2 decimal place. So the limit of accuracy there should be between what? Between the two. So the limit of accuracy will now be what? So the limit of accuracy, the limit of accuracy is 0.575 less than or equal to 0.558, then less than 0.585. So that is that. And the last one, please take that one as part of your assignment. Then I will still add like 2 to it now. So I will add like 2 to it. The assignment. I want to set this so you can see it. Assignment. So find the limit of accuracy of these two. Find the limit of accuracy of the following. If 5,760, that's the last one, to the nearest 100, B 790 kilogram to the nearest 100 kilogram, rather 100 kilogram. C, that same thing again, 78 meter to the nearest meter, to the nearest 10 meter, to the nearest 10 meter. Then D 790 kilogram to the nearest kilogram. So that is that about that. So and that's the end of the class. You do your assignment and submit it to where you usually submit. And for those of you that are doing a attachment that you solve it, you snap it, it's a very good idea. But some of you didn't monitor the attachment very well. Some people will see that their solution is in the attachment, and when I check the attachment, I will not see anything. Please take note of that, so that you should not be wasting your energy. You know, the pain of doing something and you think it has been submitted, and at the end of the day, nothing was submitted. So please, take note of that. So I hope everything we discussed is clear. So you can just have the preview. I will be expecting the solution to your assignment. Are you getting it now? So that's all. Please take note of this place. I think there is a mistake here. Please, this thing is 8 oh, instead of 7, sorry. I think it should be 8. You know it is 8, so it should be 8 oh. So, I think that's that. Okay. Make sure you change the color to the voice. So is anything else? So please make sure you do your assignment. For those of you that have not been responding to the assignment, please, I beg you,